So, hello everyone. This is Mayank Jhunjhunwala from IIT Kanpur. So, yesterday we were discussing some past year questions on coordination compounds from chemistry. So we had completed till question number 18, and so today we will be moving ahead with it. So, let's start. So, we had completed till this question, and today we will be starting with question number 19. Okay, so this is my question number 19. So it is asking me, among the following complexes, optical activity is possible in which? So optical activity means optical isomerism only. Optical isomerism. So let's see. So it is saying two CL atoms are in cis position. So basically, when I'm drawing the structure of this compound, it would be something like this: CO. Let me draw NH3 this side, NH3, NH3, then Cl and H2O. So these two Cl are in cis position. Cis means adjacent to each other. Trans basically means when they are on the opposite sides. So Cl is on the cis position, so it can show optical activity. So it is optically active when two Cl atoms are in cis position. So when this compound is in this form, it shows optical activity. But when it is like this, once again, when it is like this, CO, NH3, NH3, Cl, Cl. When it is in opposite direction, it is called trans isomer. This is trans isomer. This is not optically active. But when it is in cis form, which means that two Cl are on the same side on the adjacent positions, then it is optically active. Okay. So option number B is the right option. So this cis isomer is optically active and trans is not optically active. So among the following complexes which is possible, so option number B is the right option. Okay. Moving ahead with question number 20. An example of double salt is, so double salt is again an introductory topic which we study in coordination compounds. Okay, so for that we need to know the formula for each of these. So potassium formula is this: K2SO4 dot Al2SO4 slash dot 24H2O. So why is it double salt? Because there we have two sort of compounds separated by a dot. So please remember this thing: when we have this type of compound, it's separated by dot. So dot is separated here. So formula for potassium is like this: K2SO4 dot Al2SO4 thrice dot 24H2O. Okay, and this potassium is that only which we say fitkari in Hindi. So that is only the potassium. So it is a double salt. It is one of these things we study when we are in the starting phase of coordination compounds. So if you please remember this formula for potassium, because sometimes in the exam they directly ask you the formula. What is the formula for potassium? Or they might ask you the valency of potassium in potassium or the valency for aluminium. So how many water of coordination is being coordinated with potassium? So their answer is 24. So this formula for potassium is important. Please remember this formula. It has 24 water molecules which are coordinated with this double salt. So please remember this thing also. So example of double salt is potassium. Okay. Moving ahead with question number 21. Which of the following is the correct order of increasing field strength of ligands to form coordination compounds? So basically, this there's a table out there in the coordination compounds from where you can get the order of field strengths. So basically, you need to tell the increasing order of the field strength in the coordination compounds. Okay, so let's see. That series is called a spectrochemical series. Like in electrochemistry, we study electrochemical series. In coordination compounds, we study spectrochemical series. So, firstly, there are halogens I minus, Br minus, and then SCN minus. Why Cl minus is after that? Because it can coordinate in two ways. One is like this, and another through S. It also coordinates through S. So this is also a coordinate. Sorry. So this is also a using coordination, and this is also using coordination. Since there are two atoms that can coordinate, so its strength increases as compared to chlorine. So it comes before. So according to spectrochemical series, the order of ligand field strength is I minus greater than Br minus, then Sn minus, Cl minus, then S2 minus, F minus, OH and C2O42 minus, and so on. Why F minus is after S2 minus? Because its size is small, and S2 minus is a better ligand as compared to F minus. So this is the data, and we can compare this with each and every option. So let's see. So this is the right option. Here Cn minus is coming before C2O4, so it is wrong. Here F is coming before, again it is wrong, and here Cn is coming before, so this is wrong. This is again wrong, and this is wrong. So only this option is correct. Uh, According to this spectrochemical series. So please remember this thing because this is very important from JEE Mains point of view. Actually, this data you should mug up this data of spectrochemical series. So you can even how to learn it. You can make some sort of mnemonic. If you don't know mnemonic, you can search out there in YouTube, Google. You can get many mnemonics for learning spectrochemical series. But please mug up this series. This is quite important. Okay. So this was question number 21. Moving ahead, question number 22. The calculated spin only magnetic moment. So, spin only magnetic moment you must have read. It is given by S plus 2. So for chromium 2 plus I need to calculate. So it is again a simple one. We just need to write the electronic configuration of Cr2 plus. So Cr2 plus electronic configuration is given by argon, which is the nearest noble gas. After which, like this element is before this chromium. The noble gas which we get is argon. So we write it like this, and then 3d4. 3d4, which is chromium 2 plus. Okay. So argon 3d4. So 3d4 would be, we know that initially we have to fill each and every cell individually, then we need to pair. So 3d4 would be like this. Please don't pair it initially. Firstly, we have to do like this, and then we should start pairing. So if one more electron comes, it will come here, and then you will start pairing. Okay. So 3d4 is like this. So this is chromium 2 plus 3d4. So as I told you, spin only magnetic moment is given by SS plus 2, or whatever Nn plus 2, the designation, whatever you want to give, doesn't matter. So what is S or N? It is the number of unpaired electrons. So we can say here are 4 unpaired electrons. So S would be 4. So my spin only magnetic moment, spin only means due to spin, because they can spin since they are not paired. So spin only magnetic moment is given by under root of 4, because there are 4 uh, paramagnetic ions, 4 unpaired electrons. So 4 into 4 plus 2 would be root of 4 into 6, which is root 24. And root 24 is approximately 4.9, because you know that root 25 is 5, so you can get an approximation from there also. So 4.9 is our answer, and BM is the unit for spin only magnetic moment in SI unit. So A is the right option. You don't need to calculate root 24, please. For these kind of questions, you need to approximate it. Like we know that root 25 is equal to 5. So root 24 would be somewhere close to 5 only. So 4.9 is the nearest answer. So A is the right option. Cool. So again, this was an easy one. Just remember the electronic configuration of chromium 2 plus of chromium. It is given by argon 3d2, 3d4. Argon is again the nearest noble gas which comes before chromium. Cool. So simple question. Just if you know this formula and the electronic configuration of chromium, then you can easily do this one. Okay. So moving ahead, Question number 23. The crystal field stabilization energy, which we call CFSE, again an important topic from coordination compounds. For COCl 4 minus is given this like this. It is again in inverse centimeter. Why? Because it is inversely proportional to the length, dimension of length. So it is centimeter inverse. So the CFSE for this will be what? So basically, मेरे को COCl 4 minus CFSE is given, and I need to calculate CFSE for COCl 4. So this is changing this. Okay. So I need to calculate CFSE for this. Okay. So see, this is, you must have read that CFSE we study in two parts. First is for octahedral compounds, which are formed in octahedral complexes, and another is tetrahedral, which means the tetrahedral we have square planar also, and octahedral there is six coordinations. There are six elegans which are coordinated with the central atom. In tetrahedral there are four. So in CFSE the energy is given by delta O. So let's say it is delta O only. In tetrahedral it is represented by delta T, and it is 4 by 9 times delta O. And this 4 by 9 basically comes from two factors, both 2 by 3. 2 by 3 is due to the reduction of number of ligands from 6 to 4. Here we have 6 ligands. Here we have 4 ligands. So 2 by 3 factor comes from the reduction of ligands from 6 to 4. So 4 by 6 is 2 by 3. 2 by 3 comes from there. Another 2 by 3 comes due to the interaction, due to the what we say steric hindrance, which since 6 ligands will cause more steric hindrances compared to 4 ligands. So for that, under 2 by 3 factor comes. So overall, the crystal field stabilization energy reduces by a factor of 4 by 9. Cool. So what we are given for, since there are 6 ligands, it means it is for octahedral. And for octahedral, delta O is given to me as 18,000 centimeter inverse. So I need to calculate for tetrahedral. This is given by 4 by 9 delta O. Why tetrahedral? Because there are 4 ligands. So it will be equal to 4 by 9 times 18,000. So you can cancel it here, and you will get 8,000 centimeter inverse as your final answer. Okay, which is option number A. Cool. Again, a simple one. Just if you remember this formula, then you can do it. And why I am taking octahedral? Because here there are 6 ligands and here there are 4. And octahedral means that the central atom is being surrounded by 6 ligands. Tetrahedral means that the central atom is being surrounded by 4 other ligands. Cool. So again, a simple one. Just remember this formula. Delta T is given by 4 by 9 times delta O, and you will be good. Okay. So moving ahead with question number 24. The sum of coordination number and oxidation number of the metal in this is what? So En is as shown, ethylene diamine, ethylene diamine. Okay. So let's see. So Men2C2O4Cl. So C2O4 I told you yesterday also, it is something like this. Double O minus, double O minus. So these two minus gives it the 2 minus as its valency. So it is a bidentate ligand because of these two. It also coordinates from here also. Okay. So En is neutral ligand, bidentate ligand, of course, carries zero charge. So we need to calculate its oxidation number from here only. So let it be X. En is bidentate, it will be 0. C2O4 is -2 equals -1 because Cl is -1. So it would be +1, sorry. So X would be +2 + 1, which is +3. So this is the oxidation number given here, and coordination number is 6. Why so? Because this is also a bidentate ligand, this is also a bidentate ligand. So En will coordinate from two sides, and C2O4 will also coordinate from two sides. Okay, and since there are two ethylene diamine, So it would be 2 into 2, 4 plus 2 due to the C2O4. So total it would be 6. So coordination number is equal to 6. So oxidation number is plus 3, coordination number is 6. So total would be plus 3 plus 6, that is equal to plus 9. Okay. So please remember this thing, that don't confuse that there are 3 ligands only than Y6, because both are bidentate ligands. They will be coordinating from two sides. Since they will coordinate from two sides, so it would be 2 into 2 plus 2 for the C2O4. So total would be 6. Oxidation number is again simple. Just remember this thing, that this En is neutral compound, so it would be 0. And then you can get the oxidation number and coordination number. They are asking you to add both of them, sum. So plus 3 plus 6 would be 9. So option number A is the right option. Cool. So this is it for this question. Okay, let me draw the structural diagram of En also, just for your clarity. It is something like this: CH2, NH2, CH2, NH2. Here there are two ligands from which it coordinates, one from here and one from here. Basically, it's not like this. Let me draw it more clearly. It actually takes a form of some capturing, like it captures like this: CH2, CH2, NH2, and here also NH2. So this way it captures the electron. It basically forms a ring-like structure. So this is the way in which it approaches any central atom. So these two electrons is the reason why it coordinates in a bidentate form. And for C2O4 2 minus, I already told you. So this is about this question number 24. So, moving ahead, this is question number, once again, let me cite it. This is question number 25. The geometry and magnetic behavior of the complex NiCO4 is. So NiCO4 is a square planar compound. You must be knowing this thing. 4CO comes and coordinates like this, and it is a square planar in a single plane. All the four atoms are there. Okay. So first thing is square planar geometry. This is wrong. This is wrong. It is a square planar compound. We can see here also 4CO ligands come, and on 1 second, NiCO4. It is not square planar. I am wrong, I guess, here, because it is showing tetrahedral. So let me check it once. Okay, so it is not square planar, it is tetrahedral only, because it takes sp3 hybridization. So it is like this. The Ni is represented by atomic number 28. So its oxidation state is like this: electronic configuration AR 3D8 4s2. Okay, so when it goes to NiCO4, okay, it is like this 3D10. So it would be something like this. 4CO comes, so sp3 hybridization takes place, 2 electrons in each and every shell, so it would be 4s and 4p, because carbon takes 4 electrons in 4s and 4p orbitals, so it takes sp3 hybridization instead of square planar. So sp3, we all know it is represented by tetrahedral, not square planar. So 4CO ligands hybridize in form of sp3 hybridization, and thus complex would be diamagnetic. Why? Because every element is paired. If there would be any one which is not paired, then it would be not diamagnetic, it would be paramagnetic. But in this case, every element is paired, every electron is paired, so it is diamagnetic and tetrahedral geometry. So NiCO4 is tetrahedral and diamagnetic. Option number B is correct. It is not square planar. This is wrong. Let me erase it. It is C option is the correct option. It is tetrahedral geometry. Tetrahedral is something like this. One is going inside, one is going inside, one is coming outside like this, and two items are in the plane. So these two are in the plane, and this is going inside the plane, which means inside this region, and this CU is coming outside. Okay, so dashed line means coming outside, and this means going inside. Okay, so it is represented by tetrahedral geometry and diamagnetic. Not C, B option, sorry. Okay, so B is the right option to this question. Moving ahead with question number 26. Match the metal ions given in column 1 with the spin magnetic moments of the ion given in column 2. So this question we have done earlier also. As I told you, the formula is n into n plus 2, where n is number of unpaired electrons. Okay, so let's see. So let me write down the compounds. CO3 plus, okay, it is given here. So CO3 plus, CO3 plus, CO is cobalt. I hope you must be knowing. So it is represented by argon 3d6. So if I will draw it, it would be something like this. 1, 2, 3, 4, 5, 6. Firstly, all electrons will be drawn and then pairing starts. So there are 4 unpaired electrons. So n is 4 here. So it would be root of 4 into 4 plus 2, which is again root 24, which is approximately 4.9. Okay. So coming on to chromium 3 plus. Chromium, so you know it is a very famous compound, 24 atomic number. So chromium 3 plus is represented by argon 3d3. If I will draw this thing, it would be something like this. 1, 2, 3. So there are 3 unpaired electrons. So it would be root of 3 into 3 plus 2, which is 3 into 5, root 15. Okay. So this is for chromium 3 plus. So let me make some space. For Fe3 plus, it is argon 3d5. You just need to, and if you know the electronic configuration, then it is quite simple. You just need to draw the orbitals. So see how fastly I have drawn, because I know that there are 5 electrons, so it would take each and every shell once, and then pairing starts. So from here I can see there are 5 unpaired electrons. 5 unpaired electrons. So it would be root of 5 into 5 plus 2. It will give me root 5 into 7. That is root 35, as shown here. Okay. Coming on to last, Ni2 plus. So we know that nickel is represented by 28. So it would be argon. If I write for nickel, it would be argon 3d8 4s2. But since it is 2 plus, so this 2s electrons will go. So I would be left with 3d8 only. Okay. And now if I will draw 3d8, it would be 1, 2, 3, 4, 5, then 6, then 7, then 8. So there are 2 unpaired electrons. So again, using the same formula, root of n into n plus 2, we will get 2 into 4, which is root 8, which is shown here. Again, Bm is Bohr magneton. Bm is Bohr magneton, the unit for spin only magnetic moment. Bohr is the scientist for which this unit came. So these are the options. For cobalt 3 plus, it is root 24, which is option number 4th. So this one, and for Cr3 plus, it is how much? It is root 15. So it is 5th. So B 5th. So option is A, option is the right option. Okay. So A is the right option. Again, a very simple question. If you just know the electronic configuration of each and every atom, which you must be knowing because it is nothing but 3D series, and you need to learn the electronic configuration of each and every element from 3D series. There are only two exceptions of chromium and copper, which you must be knowing. So if you know the electronic configuration of all the 10 atoms, of all the 10 elements in this 3D series, then this question is quite easy. This formula is again a simple one. If you don't remember this formula, please learn it also. N is the number of unpaired electrons here, which you will be getting when you will be forming the 3D shell diagram. So it is number of unpaired electrons. Cool. So this was my question number 26. Moving on to question number 27. Correct increasing order for the wavelength of absorption in the visible region for complexes of CO3 plus. So basically, it is asking for increasing order and for wavelength of absorption. Wavelength of absorption. Okay. So again, it is given by, firstly, you need to know the strength of ligands, which you can see using spectrochemical series. So we know that En is better than NC and H2O. Why? Because En is bidentate ligand. Then NC and then H2O. Why so? Because nitrogen is better donor as compared to oxygen. Okay. So En is better than NH3 is better than H2O. So for strong ligand, the value of delta O for the complex is higher. I think you must be knowing that the absorption wavelength they are asking is for CFSE, which is for crystal field stabilization energy when the electron jumps from one shell to another. So the value of delta naught for the complex is higher for strong ligand because this is a general property of crystal field stabilization energy for octahedral complexes that delta O is directly proportional to the strength of ligand. That is, if a ligand is placed higher in electrochemical series, in spectrochemical series, then delta O will be higher for it. So hence the increasing order of wavelength would be directly proportional to the increasing order of strength of ligand. So it would be En for it would be COEN3 3 plus, then ammonia, and then H2O. Okay. For strong ligand, the value of delta of all the complex is higher. That's why. So that's why. So and you need to know for wavelength. Wavelength is inversely proportional to delta O. So it is inversely proportional to strength of ligand. Okay. So increasing order would be something like this. Delta O would be highest for this. Delta O would be highest for this one, then this, and this. And wavelength is inversely proportional to delta O. So this is the right order. Right order. Higher value of delta O means higher stability, which means it will absorb higher energy photons. Higher energy photons have low value of wavelength because lambda is inversely proportional to energy since E is given by hc by lambda. So please remember this one thing that delta O is directly proportional to strength of ligand. Delta O means splitting energy in case of octahedral complexes. Strength of ligand and wavelength is inversely proportional to delta O, which means it is inversely proportional to strength of ligand. Okay. So you just need to know the spectrochemical series, and according to the spectrochemical series, you can arrange these compounds. So En, NH3 and H2O, which is option number D1. If you have been asked the order of delta O, then the order would be opposite. In case of delta O, the order would be like this, then this, and then this. Okay. So it is opposite for delta O, and wavelength is inversely proportional to delta O. So the option is the right option here. Cool. So moving ahead with question number 28. HgCl2 and I2 both were dissolved in water containing I minus ions. Okay, so basically here you need to know the reaction. They are saying that HgCl2 and I2 are dissolved in a water, and this water contains I minus ions. Okay, so it would be something like this. These two reactions will take place in a solution containing HgCl2, I2 and I minus. Both HgCl2 and I2 compete for I minus because both want I minus. I minus is a strong ligand. Since formation now how it would be formed, it would be formed according to the Kf, which means the value of the reaction for which Kf is higher would compete and win as compared to other one. So formation constant of HgI4 2 minus is higher. So it will be formed rather than other reaction. It is 1.9 10 power 30 as compared with I3. So the Kf for I3 minus is 700 and for HgI4 2 minus is 1.9 into 10 power 30. So it is 10 power 30, it means it is 10 power 28 times higher than this. So of course this reaction will take place. So reaction is like this. HgCl2 will react with I minus, which is already there in the water, to form precipitate of HgI2, and 2Cl minus would be released. Other reaction would be HgI2 will react with 2 minus again to form HgI4 minus. And why this is forming? Because its Kf is very high, 1.9 into 10 power 30. Kf is what? Kf is formation constant, which we study in equilibrium. It is given by when this thing, one second. When you study equilibrium chapter, then you study about the formation constant. It basically represents what is the tendency of reaction to move in forward direction. That is the reaction really wanting that its reactants can convert into product or not? This is represented, that is the tendency of reaction is being represented by this formation constant. So of course, it is Hj I4 2 minus is very large as compared to I3 minus. That's why I can say that this reaction will take place as compared to I3 minus. I3 minus one reaction would be like this. I2 will react with I minus to form I3 minus. So this is quite a different reaction. Its Kf is 700. This will also take place, but in a very, very small amount because its Kf is very small as compared to this one. So finally, I would have IgI4 2 minus as the precipitate. Not precipitate, precipitate is this one. It is a red PPT. So HgI4 2 minus would be formed, which would be soluble. So HgI4 2 minus and I3 minus, these are the two things which I will get. Okay. So option number B is the right option. I3 minus would be in very small amount because this reaction is very fast. Since Kf is very large, Kf of formation of Hg I4 2 minus is very, very large as compared to I3 minus. So this will be formed, or this would also be formed, but in a very small amount. So B is the right option to this question. Okay. Moving ahead. Question number 29. Pick out the correct statement with respect to MnCN6 3 minus. So basically, this is for this I need to know the oxidation number of Mn. Let it be X. So X minus 6 is equal to minus 3. So it would be plus 6 minus 3, which is plus 3. Okay. So Mn is in plus 3 state, Mn 3 plus. We know that Mn is 25. So it would be argon 3d5 4s2. Okay. So in case of 3 plus, it would remain argon 3d4. So let's see. See, argon 3d4. So 3d4 I know. Firstly, I need to fill each and every shell and then I will start pairing. So 3d4 would be like this. Cool. The compound is MnCN6 3 minus. MnCN6 CN6 3 minus. Okay, so there are four CN ligands, and I know that CN is a strong ligand. So strong field ligand CN minus, it will cause pairing of electrons. So this electron will pair with this, and you will be left with this. Okay, so now I can see my 4s is empty, my 4p is also empty. So there are 2d, 1s, and 3p. So it would form D2sp3 hybridization. And why it is forming so? Because there can be only two possibilities, either D2sp3 or sp3d2. But how we decide between these two? This can be decided using strength of ligand. Basically, it is decided using strength of ligand only. If the ligand is stronger, then it will force the unpaired electrons to pair and it will empty the inner D shell. So we will get D2sp3. If the ligand is not stronger, then in case of D2sp3, we will be getting sp3d2 because this D shell would not become empty and I need to take S1, P1, and the ahead D1. So here the ligand is strong, so I will pair it and I will be left with 2D earlier. So I will form D2sp3 hybridized ligand. So there is D2sp3 hybridization and I will form basically this Cn minus ion would come and attach with these Mn in these six shells. Okay, so it will form D2sp3 hybridization. Okay, so D2sp3 hybridized and octahedral. Why octahedral? Because it is six ligands, and six ligands means octahedral complex. Okay. So again, a simple one. Just remember this thing that Cn minus is a strong field ligand, strong field ligand, and it will force pairing of electrons. Pairing of electrons. Okay. So it will pair the electrons, and we will get D2sp3 hybridization. So this is wrong, this is wrong, and ESP2 also wrong. D2sp3 is the correct option, which is octahedral. So this is the right option. You can even eliminate this because first thing, it can be octahedral only, it can be tetrahedral. So these two options are already eliminated. So you only need to look for these two options, and D2sp3 is the right option. Okay. So moving ahead with question number 30. Which of these statements about COCN6 3 minus is true? Again, you need to firstly draw the D shell diagram. So cobalt is 3d7, argon 3d7, 4s2. So again, calculate its oxidation state. It will be x minus x equals minus 3. So x would be plus 6 minus 3, that is plus 3. Okay. So cobalt 3 plus, it would be like this. Argon 3d6. Cool. So cobalt 3 plus would be represented like this. 3d6. So 1, 2, 3, 4, 5, and 1 would pair. Cool. So yes, it is 3d6, 4 is 0. So I will draw it here again. 1, 2, 3, 4, 5, 6. Again, as I told you in the last question, Cn is a strong field ligand. Cn is a strong field ligand. So it will force pairing of electrons. Pairing of electrons. So this will get paired here and this will get paired here. So you will get 1, 2, 3, 4, 5, 6. So this 2D will become empty. So again, you will get D2sp3 hybridization. Okay. Same logic as the last question. There are only two hybridization possible, either D2sp3 or sp3d2. It depends upon the strength of ligands which will form. If the ligand is stronger, then this will be preferred. Otherwise, this will be preferred. But here again, the ligand is Cn minus only, cyano ligand. It is a strong ligand. So D2sp3 hybridization will take place. So D2sp3 hybridization will take place. There are no unpaired electrons. Four unpaired electrons is wrong. So either this one or this one. And low spin or high spin. I know that spin is given by root of n plus 2, where n is the number of unpaired electrons. But in this case, I can see that number of unpaired electrons goes to 0. So spin would be 0 only, which means low spin. Okay, why? Because there are no unpaired electrons. So it is no unpaired electrons and low spin. So option number D is the right option to this question. Cool. What is high spin and low spin? If you are confused there, high spin means there is some sort of spin configuration. Low spin means there is no. Here it is 0, so it is low spin, and there are no unpaired electrons. So option number D is the right option. Again, the same logic. If you see Cn minus or any strong field again, the configuration would be D2sp3 in case of octahedral. Octahedral means when there are 6 ligands. Cool. So option number D is the right option. Moving ahead, question number 31. The anion of acetylacetone ACAC chelates with CO3 plus. The rings of the chelate are. So again, this is a chelating ligand. Chelating ligand means forming a ring. So it forms a ring. So C, the ion is ACAC. Again, 2 minus, the same which I am telling you again and again, something like this. Okay, so it forms a chelate. How it forms a chelate? Since it is a bidentate ligand, so it will coordinate from two places: 1, 2, 3, 4, 5, 6. Why? Because there are is 3 ACAC ions. So basically 3 into 2, 6 ligands will coordinate. So 6 oxygen. So basically it will form 6 membered rings: 1, 2, 3, 4, 5, 6. 1, 2, 3. Let me do it once again. It will draw 1, 2, 3, 4, 5, 6. So it will form 6 membered rings. So 6 membered rings are like this. So option number D is the right option to this question. Okay. Okay. So 6 is the right option to this question. Moving ahead. Question number 32. Among the following complexes, the one which shows zero crystal field stabilization energy, CFSA, is 0. So I need to know that compound which will give me 0 CFSE. So 0 CFSE would be, for 0 CFSE, I need D5 configuration. I know that D0, D5, and D10. These three configurations give me 0 CFSE for octahedral complexes. Octahedral complexes. So I need D5 configuration. So let us check again. Mn is 25. Here the oxygen state of Mn is given by, again let it be X. So X, H2O is a neutral ligand, X plus 0 is plus 3. So X is in plus 3 state, plus 3 state. So Mn is given by 3d5, 4s2. Okay. In plus 3, 2s will go and 1 will go from here. So you will be left with 3d4. But you need d5. So A is not the right option. Let me clear the space. Checking for Fe. Again, same logic. H2O is neutral ligand. So Fe would be 3 plus. And Fe is 26, which is 3d6, 4s2. sorry, 3d6 4s2. So when three electrons will go, two will go from here and one will go from here. So we will be left with 3d5, and d5 is all which we want, is all what we want. So B is the right option to this question. We can check others also. Cobalt H2O6 2 plus. Cobalt is 27, which is 3d7 4s2. So here it is in +2 state. So these two will go and you will be left with d7, which is wrong. I need d5. Let's check with this. Again, it is 27. It is 3d7 4s2. Here I need three electrons to go. So two will go from here, one will go from here. You will be left with d6. Again, it is wrong. I need d5. So option number B is the only option which is giving me 3d5 configuration. So option number B is the right option to this question. So the right option is Fe. Please remember this thing that in case of octahedral complexes D0, D5, and D10 are 0 CFSE. Cool. I hope you got that. Let's move ahead. Question number 33. Which among the following is a paramagnetic complex? Paramagnetic means unpaired electron. Unpaired electron. Okay. So atomic number is given to me, molybdenum 42, platinum 78. So D is the right option. D is this option, COBr4 2 minus. COBr4 2 minus. I know cobalt is 27. So it would be argon 3d7 4s2. Let's calculate the coordination oxidation state of cobalt here. It would be x minus 4 equals minus 2. So x would be +2 here. So when I will do +2, this 2s electrons will go, and cobalt 2 plus would be argon. Cobalt 2 plus argon 3d7. So when I will draw 3d7, 1, 2, 3, 4. So 3d7 would be like this: 1, 2, 3, 4, 5, 6, 7. So I'm having 3 unpaired electrons. Since I'm having 3 unpaired electrons, so it will exhibit paramagnetic behavior. You just need to find out in which of the following you are getting unpaired electrons, and unpaired electrons means paramagnetic behavior. Okay, so option number D is the right option. Why so? Because in this I am having 3 unpaired electrons. Okay, so option number D is the right option. Moving ahead with question number 34. Which of the following complexes is used as an anti-cancer agent? So this is a remembering question. What you say, you need to mug up this type of questions because these are not asked in JEE Advanced. These are asked in JEE Mains. So at least from JEE Mains perspective, you need to learn these questions, and these are given in the NCERT only. If you mug up NCERT, then it is very much for JEE Mains. So it is from NCERT only. So anti-cancer agent is cisplatin. Cisplatin. Okay. So directly from NCERT. Cool. Cisplatin is the right option. So option number B. Latin formula is this: PtCl2 NH3 twice, not bromine. Okay. So cisplatin acts as an anti-cancer agent. Okay. So moving on to the last question for today. Question number 35. Which one of the following is the outer orbital complex and exhibits paramagnetic behavior? Okay, so again I need to draw. So nickel is 3d8 4s2. So it is two. It is in 2 plus state here. So this will go, and this would be 3d8. So 3d8 would be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So ammonia is again a strong ligand. As shown here in ST6 3d8 according to CFT, it would be T2G6 EG2. So hybridization is P3D2 and complex is paramagnetic and outer orbital. Why so? Because here we have two unpaired electrons. So I need six ammonia. So I can't pair it here inside. So I need to use outer S and outer P and outer D shell. So it is SP3 D2, these two, these three and these two. Why so? Because I need octahedral complex, and for octahedral, I either would be D2sp3 or sp3d2. And I know that ammonia cannot force pairing of electrons, so I can't use inner D. So I need to use outer D. So it would be outer orbital complex sp3d2. Okay. And paramagnetic also. Why so? Because I have two unpaired electrons. If it will pair also, then also it will give D only. So pairing, if you give me the logic that ammonia is a strong field again and it can pair, then the reason is that if you will pair also, then only one D shell would be left. And but you need D2sp3. You can't form something like this dsp3d. This is not possible. So if even if you pair, you would be left with only one d shell, so pairing will not work here. You need to use outer shell only. So for that I need to use outer shell, so my electronic configuration would be sp3d2 and two unpaired electrons will remain. Two unpaired electrons will be remaining, so it is paramagnetic also and outer shell also. So option number A is the only right option. I need to check, I don't need to check the rest ones. Okay. So here the coordination compound chapter ends. I think we discussed a lot of questions from previous year JEE Mains. And even if you are able to do these questions, these 35 questions correctly, then you are prepared for JEE Mains. Just remember three, four things. Spectrochemical series, you should remember. You should know isomerism and certain things which you need to mug up, as I told you about cisplatin. These three, four things, and about kick to CR2, kick to CR207, KMNO4, about CFSE basics. If you know these three, four things, then you are good to go for JEE Mains. You must have got a better idea about the questions as we have solved. So yes, this was all it for coordination compounds. Not a chapter which I would say an easy one, but you can do it if you are preparing for JEE Mains at least. For JEE Advanced also, there are certain tough questions on isomerism, but you don't need to worry it for JEE Mains. Even if you are able to do these 35 questions, then you are good to go for JEE Mains. So this is it for coordination compounds. Okay, so let's end this. We'll meet again in our next session. Okay, thank you. Bye.